Hi everyone, my name is Khaled and I'm the CEO and co-founder of LabsCubed, and at LabsCubed we revolutionize material testing through smart hardware. So generally speaking, making materials like rubbers or plastics or adhesives or metals is a very difficult, time-intensive and expensive process. And I kind of saw this through my master's, where I saw the development of a new adhesive for the automotive industry. And they were still in year 10 of the development cycle by the time I had finished. And I wanted to know, why does it take so long? Why is it so complicated? So speaking to customers, speaking and learning more and more in the industry, what we found is most people go through this very repetitive material creation process. You start out with certain properties that you're trying to hit, whether they're customer driven or driven by the industry generally speaking. You know, for example, if you're trying to make a new rubber, you need it to have a certain strength. You need it to be able to stretch a certain amount. And so what you do is you go through your past materials that you've made, past rubbers that you've made, and your chemist will then pick a certain formulation or recipe that you think will get you close to the properties that you're trying to hit. You then send that information off to the R&D team. The R&D team then takes that, creates that material physically, that rubber physically, a physical slab of it, and then they test it. So they test it to destruction. They pull it until it breaks, they crush it, or they bend it, and they collect data about it. That testing is usually done very manually. A technician sits there in front of a machine all day testing one sample at a time. Once that testing is completed, you have a lot of data that you collect, like the strength, elongation, etc. You have to manually analyze it. So that is then analyzed. You see how close you are to kind of the properties you were trying to hit. Go back, refine your material a little bit, and repeat. And you'll see that they'll do this thousands of times before they get to a final material. And so we looked at this and we thought, all these manual aspects, how can we speed them up? How can we make them better? So what we've done is we've created an end-to-end workflow solution. And our platform, essentially, there's a hardware aspect to it, specifically made for the rubber and plastics industry, and there's a software aspect. In terms of the hardware, called the Cube One, it essentially automates the highest volume testing that they do today in rubbers and plastic, in the rubber and plastic industry. Instead of a technician sitting there doing one at a time, you place in 12 samples, put it in the machine, press start, and walk away. And that kind of automation starts to really speed up that process, more accurate, more consistent data. In terms of the software, it's a Cube One portal specifically for the machine itself. It is an IoT device, the machine. So we're collecting all that data centrally into a cloud-based system, which is something they don't have today in most manufacturing plants. And we give them those smart insights. We analyze and give them that data so the chemists can make faster and better decisions based on the tests that had occurred. Currently in the middle of a CENGN project to test the scalability of our system. So looking at kind of a bigger picture of the customers connecting into the compounders who make the rubber or the plastic themselves, what we're specifically doing today is the Cube One portal is really only connected to our machines. Much of their other stuff isn't cloud-based. This is kind of the first IoT devices that they might be putting in. So where we're working towards in the future is an enterprise software system, something where we collect those multiple divisions that you saw all into one centralized location. Second thing that's really important in terms of an enterprise software system is, can we standardize all the formats for all the data that they're producing? Currently, they might have images of things, they might have random Excel sheets that are all in different formats. Can we standardize that to allow them to be able to use it in the future for a plethora of things? The third thing that we found is we actually create videos in our testing. Some of the infrastructure that's currently there in terms of the internet they have, the speeds aren't that great. So in the future, a 5G infrastructure, if implemented correctly, could help to alleviate some of those issues, as opposed to asking our customers to have to change all of their internet protocols and rebuild everything from that point of view. We can come in with a different solution. So this is going to become extremely important in manufacturing. So looking back to that bigger picture, where we want to go in the future, what we're working towards now is kind of a bigger enterprise software system that can connect the sales, R&D, and production, which currently in most places are kind of siloed and on their own. And big picture here, there are a whole bunch of modules that we're looking at. So we're looking at the sales side of things. We're looking at how customers are going to be able to interact with this new data and this new central system, how we auto-analyze a lot of this data, clean it up, format it to a similar format. Of course, all this leading into some kind of AI or machine learning so that they can use predictive modeling and they can use these new systems to speed up any of their processes along the way. So that's kind of where we're going in the future, and that's where we're working on today. Thank you so much, everyone, for listening. And if you have any questions, please feel free to reach out. Thank you.